Okay, so today we're going to use the elimination method or the linear combination method to solve some application problems. So let's look at our first example. A store sold 28 pairs of cross-trainer shoes for a total of $2,220. The Reeboks sold for $70 a pair and the Nikes sold for $90 per pair. How many of each were sold? Okay, so with these kinds of problems, we have two different pieces of information given to us. We have the total number of pairs of shoes that were sold, and then we also have the amount of money that was made off selling these 28 pairs of shoes. And then they give us a little bit more information. They're telling us that the Reeboks sold for $70 a pair, and then the Nike sold for $90 a pair. So how many of each style were sold? Okay, so the first thing we have to kind of look at is figure out, well, what are the two different things that we're kind of looking at in this problem? So in this particular situation, we're looking at two different brands of shoes. So we would want to give each of those a variable. So one of those would be the Reeboks in this situation, and the other one would be the Nikes. Okay, so now when we come up with our equations, there's two things happening here, right? So we know that this 28 pairs of shoes, so we had the number of Reebok shoes sold plus some amount of Nike shoes sold, and that equaled a total, right? So when we do our equations, we want to do one equation that involves the quantity, and quantity is how many of something. Okay, so how many pairs of Reebok shoes were sold? I don't know, so that's going to be X, plus how many pairs of Nike shoes were sold? Again, I don't know, so it's going to be Y. But we do know that together there was a total of 28 pairs sold. Now, the other three numbers that you'll notice in this problem all have dollar signs on them because they're all referring to the cost. Okay, so now again, we can still kind of use our general verbal model up here at the top. The Reeboks plus the Nikes equals the total. But the first equation involved the actual number of shoes sold of each type and the total. And then the second equation is going to involve, well, how much money did the store make on the Reeboks? How much money did they make on the Nikes? How much money did they make total? So how would you figure out how much money they made selling Reeboks? Well, we know that they're $70 a pair. So I'm going to say 70 times X, because however many pairs we sold would be X, and we're multiply that by 70. Then for the Nikes, those were $90 a pair, so that would be 90Y. And then our total that we made was $2,220. So now once you have your two equations set up, you can really use any method to solve it. But when you have these cost versus quantity types of equations, usually the easiest method is this elimination or linear combination method because they're already set up for us in standard form. So I'm going to go ahead and rewrite these two equations over here just so that I have a little bit more room to work with them. So X plus Y equals 28, and then I have 70X plus 90Y equals 2,220. Now, if you remember from the method that we've been working on, this elimination method, we would want to somehow make it so that when we add the two equations up, either the X variable cancels out or the Y variable cancels out. Now, because the first equation is just X plus Y equals 28, you can easily make that the opposite of 70x. So I could easily multiply it by negative 70 and make it negative 70x, or I could easily multiply it by negative 90 to make it negative 90y. So it doesn't matter which one you want to do. Usually when I don't have, if I have more than one option, usually I choose the smaller number. So since 70 is smaller than 90, I'm going to do negative 70. So now once you do that, we now want to multiply that negative 70 to our entire equation. So that will give us negative 70x, negative 70y or minus 70y. And then we would have to multiply 70 by 28, which would give us 1960. And of course, it's going to be negative 1960 because we multiplied by negative 70. Now, the second equation, we should be able to just leave it as is and recopy it. All right, so now at this point, I've successfully set it up so that when I go to add these or combine these two equations, my x's are going to cancel. And now 90 and negative 70 gives me 20y, and 2,220 minus 1960 is 260. And then, of course, we would continue to get the y alone by dividing by 20. And that would give us 13. Now remember, what is that 13? Well, we had initially given y, the variable y, we assigned that to the number of Nike shoes that we sold. So this means that we sold 13 pairs of Nike shoes. So now that we know how many Nike shoes we sold, if we go back up to our original problem here and use one of these equations, and usually this quantity equation is going to be the easiest one. If I have X amount of Reeboks plus 13 pairs of Nikes, and that's a total of 28, how many Reeboks were sold? Well, all I have to do is subtract the 13 pairs of Nikes from the total, and I'm left with 15, right? 15 pairs of Reeboks. And that's it. So just make sure, because it is an application-based problem or real life type problem, that your answer, while you could write the answer as 15, 13, that wouldn't have very much meaning unless you gave those numbers labels. So in this case, you would want to say 15 pairs of Reebok shoes were sold and 13 pairs of the Nike shoes were sold. All right, so we're going to do another similar type of problem. In one day, the National Civil Rights Museum has collected $1,596 from 391 people. The price of each adult admission is $6, and people of the ages 4 to 17 pay a reduced admission of $4. So I'll say that's like child tickets, essentially. So what are the two things that we're looking at in this problem? Well, we've got adult admissions, and we have this reduced admission here for children. So I would make one of those X and one of those Y. So I'm going to make X adults or adult tickets, however you want to write that. And then Y, instead of writing reduced admission, I'm just going to write child. Or you could write kids or whatever. Okay? So we have our adult tickets and our child tickets. Now again, we have two equations we need to come up here with. So we have quantity, so that's going to be how many tickets were sold, and then we have the cost factor. So again, we want to know how many adult tickets plus how many child tickets equal a total. So let's do this in terms of quantity. How many adult tickets were sold? We don't know, so we're going to make that X. How many child tickets were sold? We don't know that either, so we're going to make that a different variable. Why? Because they could be different amounts. But we do know the total was 391 people, so that's the quantity. So X amount of adults plus Y amount of children equals 391 total people attending this museum. So now the second equation is going to be our cost equation. So really all you have to do is use the numbers that had the dollar signs. So we know adults is $6, so I'm going to make that 6X. And then children is $4, so that would be 4Y. And then that's going to equal the total money collected because it has the dollar sign, so $15.96. So just make sure that the three numbers that have the dollar signs are all going to go together in that same equation. And then the number without the dollar sign is going to go in your simple equation, which is just x plus y equals 391. All right, so now I'm going to recopy them over here just so I have a little bit of room to work with them. All right, so just like we did on the last problem, we have two equations here. They're both in standard form. Our x and our y on our left, our constants on our right, so that's all good. So it's really set up really well for this elimination method. So what do I want to eliminate, the x or the y? Well, I have options, right? I could multiply my first equation by -6 to eliminate my x's, or I can multiply my first equation by -4 to eliminate my y's. So I'm going to do the y's this time because 4 is smaller than 6. So I'm going to multiply by -4. So that's going to give me -4x minus 4y. And then I'm going to multiply 391 times that -4. And I'm going to get -1564. The second equation can now just be copied over as is. And now I can combine. So -4x and 6x is going to give me a 2x. The y's are going to cancel because that's what I did to set it up. And then 1596 minus 1564 is going to give me 32. And then, of course, I would just divide by 2 so I could finish up this problem. Whoops. Got a little funky there. And we get x equals 16. So again, what does that x represent? Well, the x over here, we decided represented adults. So that means there are going to be 16 adults attending this museum. So now I want to figure out how many children. So again, the number of adults plus the number of children equals the total, right? So I'm going to use the equation that's a little bit simpler to work with. I know that I have 16 adults plus Y amount of children, and that's going to equal the total people, which was 391. So if I subtract these number of adults from my total, 391 minus 16, I'm going to get 375, and of course that is going to represent children. Okay, so we had 16 adults and 375 children. All right, so we got one more problem here using this cost and quantity setup. So in early spring, buy 6 potted tomato plants for your garden. The plants contained in the small pots sell for $5, and the ones in the large sell for $8. If you spend a total of $36, how many of each are you buying? So a lot of times you'll go to a garden center and they might have smaller ones that are not quite as grown, but they're a little bit cheaper. And the more mature plants are a little bit bigger and they're a little bit more expensive because chances are they're going to be a little more successful if you plant them and things like that. So again, we have two different things that we're trying to figure out, how many smalls and how many larges. So we're going to give each one a variable. Doesn't matter which one's x and y, just pick one and then stick with whatever you pick. So I'm going to do the smalls for x and large for y. Okay, so again, I have to come up with my two equations. I'm going to have a quantity equation. That's going to be how many. And then I'm going to have my equation with all my dollar signs, which is going to be the cost. And again, my verbal model here is the smalls plus the larges equals the total. So let's look at that first with respect to quantity. How many? How many small pots are we going to buy? We don't know. That's what X is representing. How many larges are we going to buy? We don't know. That's what y is going to represent. But we do know we bought 6 in all. So that's our first equation, x plus y equals 6. So now what would the cost equation be? We have 3 numbers with dollar signs, a 5, an 8, and a 36. So which number is going to go with the x? Well, x is representing small, and those are selling for $5 each, so it's going to be 5x. And then the $8 each is for the large, which is our y, so that will be plus 8y. And then our total amount of money is $36. And now you can use any method you want to solve this. However, I believe that elimination method is definitely the go-to since they're both set up for you in standard form. However, if you did like substitution method or something and you just wanted to get the y by itself or the x by itself and substitute, that also works. So in this particular problem, I'm going to multiply my first equation by something, and I can either do -5 or -8 to get either the x's or the y's to cancel. Either one will work. So like I said, usually when I'm not sure which one to pick, I just pick the number that's smaller because I figure it's just probably a little bit easier to multiply by. So now I have -5x minus 5y equals -30. And then the second equation is just going to stay as is. And now I can add these up. My x's are going to cancel. -5y and positive 8y is going to be 3y. And then -30 and 36 is going to give me positive 6. And then I can get my y, which is 2. So remember, I found my y first here, so that's going to represent my large one. So I have 2 large. So if I take a look at my quantity equation, which was the simpler one, if I know x plus y equals 6, and I just figured out that I'm going to have 2 large, I substitute that in for y, so I can subtract the large ones from the total, which leaves me with 4 small. And there you go. And that's how you solve a problem, a cost versus quantity problem using the elimination method.